So the atomic masses of isotopes of silver Ag107 and Ag109 are 106.906 AMU and 108.868 AMU respectively. Means untuk Ag 107 ni dia punya atomic mass. Lepas tu kalau Ag 109 ini dia punya atomic mass. Okay, if the relative atomic mass of silver is 107.868, another information is given here is about the relative atomic mass. Kalau perasan sini dia tak ada unit kan?
Betul, Miss.
Yang lain tu semua ada. So yang ni belongs to atomic mass biasa. Satu lagi adalah relative. Sekejap silap. Relative atomic mass tak ada unit lah. Okay, determine the percentage relative abundance of these two isotopes. So how are we going to start doing this? Given already the informations about the isotopic mass, and then you need to find the percentage abundance.
Let X and Y.
Yes, awak nak cari abundance dalam bentuk percentage, total kena 100% for these two, 107 and 109 silver. So awak kena start with let percentage of these 107 silver be X, and then percentage of 109 silver is Y. Okay, and then these two kita tahu X plus Y equal to 100. Alah, waktu Nila dia nak potong rumput. Alah, dengar tak?
Dengar. Orangnya tak potong.
Dengar.
Dengar Suara saya dengar tak?
Dengar.
Suara saya dengar? Kejap. Okey. Dengar. Dia dah pergi dah. Okay, so dekat sini awak akan diberi 1 mark. 1 mark kita bagilah dekat sini. Kiranya kalau complete this one, bagi 1 markah. And then you are going to substitute this into the formula of apa? La ilaha illallah, makin dekat. Formula of apa?
Average atomic mass.
Average atomic mass awak. So average atomic mass kita tahu what is the nominator?
AMU times abundance.
Yeah, AMU times abundance divided by
Abundance.
abundance. Your abundance now is 100 lah. Okay, so kita akan substitute value. You have your atomic mass, average atomic mass. Tapi kalau case ni dia dah bagi dalam RAM, boleh juga kita guna. So terus je ambil. Awak ni lah. So 107.868 equal to. So kita punya isotopic mass for 106.906. Kita akan darab dengan X. And then the other one gonna be 108.868Y. Okay, and then divided by 100. Okay, so lepas tu awak pun tadi tu lupa nak buat. Ini kita let jadi equation number 1. This one kita akan let as equation number 2. Okay, and then we are going to substitute sebab now at the moment kita ada these two unknown. Kita akan substitute one of them 1 into 2. So subs 1 into 2. Once kita subs 1 into 2, kita akan dapat, saya terus masukkan awak akan dapat dan awak akan darab 107,868 ni darab dengan your denominator 100, you will get 107.86.8 equal to, so saya akan dapat, nanti saya kembangkan, 10690.6 minus 106.906Y. Kecil bawa ke bawah lah. Kejap okay, kat sini. Ambil tu. Lagi kita ada plus 108.868Y. Mana saya dapat this expansion? Saya akan substitute tadilah 1 into 2. And then lastly, your X will be berapa? Y dapat berapa? Sekarang kita dapat Y dulu kan?
Betul, Miss.
Y dapat berapa? Saya nak jawapan awak cepat. Awak dah buat kan? Hai, cepatlah.
49.03.
Yes, 49.03. X awak adalah 100 minus this value. You will get 50.97. Boleh tak kita stop terus? Ini dia punya answer?
No.
No.
Tak boleh. Awak kena buat final conclusion. Therefore, kena restate balik. Percentage untuk 107 AG will be 50.97%. Percentage for 109 silver will be 49.03%. So your 4 marks comes from the first one daripada lead, and then the second one you form these second equations, and then you get both X and Y not yet in percentage, and lastly you get this one. Sometimes dekat yang markah ketiga tak bagi, dia bagi 1 each dekat percentage yang awak dah bagi tahu final answer. So 4 marks here. And then for question 2, chapter 2, if the energy difference between the ground state of an atom and its excited state is 5.4 10 to the power of negative 19 joule. So this energy difference, can I know what is the symbol for energy difference?
Delta E.
Yeah, delta E.
Delta.
Got a number of formula for delta E. So baca elok-elok. What is the wavelength? So dia bagi awak delta E, dia nak minta awak cari wavelength. And dia dah specify in nanometer. So awak nak guna formula yang mana dalam banyak-banyak delta E?
HC over lambda.
Yes. So you're going to take this delta E equal to HC over lambda. So you already have your delta E, you have your lambda. Sorry, you want to find the lambda, you already have your H and C comes from the table of constant. So you simply rearrange your lambda on the left hand side and everything else kita bawa ke kanan. So HC over delta E. Nanti awak akan dapat H awak adalah 6.6256 10 to the power of negative 34 times with 3 10 to the power of 8 is the speed of light divided by kita akan divide dengan 5.4 10 to the power of negative 19. So from here you will get hello?
3.681
Okay,
times
3.6
10 power negative 7.
Yeah, 10 power of negative 7. Can I know the unit here? Meter or nanometer?
Meter.
Meter. But the
Meter.
questions already specified they want in nanometer, right?
Yes.
So macam nak tukar nanometer?
Times 10 power 9.
Okay,
Betul.
nanti awak akan dapat 368 pun boleh, 368.1 pun boleh, nanometer. So your marks comes from, sebab dia 3 minit tadi 2 markah je. Jadi 1 markah dari awak punya substitution, 1 markah final answer nanometer. Kalau stop sampai meter tak dapat markah.
Miss,
Okay.
Kalau decimal place lebih tak apa?
Apa?
Decimal place.
Tak ada masalah.
Okay.
Okay.
if we take the previous answer and times the whole thing by 10 power 9.
Kalau dia dapat berapa, dapat tak number yang sama ni?
Mhm.
Dapat, boleh lah. Boleh. Okay. Then, question number 3. Predict the directions of the net reactions when 0.55 mole N2, 0.80 mole H2, and 0.025 mole NH3 are mixed in a 2.5 liter vessel at 1000 Kelvin. The equilibrium constant Kc for the reactions is 2.4 10 to the power of negative 3 at this temperature. So, dia minta awak predict the directions. Bila sebut predict the directions, awak nak kena cari apa?
QC.
Ya, QC. Dia dah bagi belum KC?
Dah.
Dah.
Okay, sekarang ni awak kena cari QC dululah sebab dia minta awak cari predict the directions. So kalau awak perasan dia bagi semua value, N2 ada, H2 ada, NH3 pun ada the value. But at the moment they give you only in mole. Can you already take this number and then put it in your QC expressions?
No.
No, you need to first find the molarity, the concentrations because of this C. So can divide dulu your number of mole with this volume. Okay, so by calculating your concentrations for each species for N2, awak buat calculations lain, saya bagi awak terus jawapan akhir, 0.22 molar. Concentrations of H2, awak akan dapat 0.32 molar. Concentrations of NH3, you will get 0.01 molar. And then you know your QC expressions will be, apa QC expressions awak?
NH3 power 2
Ya,
Over
over
N2 times
dengan
H2 power of 3.
H2
ya, H2 power of 3. Okay, so sekarang ni kita dah ada these expressions, terus masukkanlah value yang kita cari tadi. NH3 kita is 0.01 square divided by your N2 is 0.22. Then we have our H2 raised to the power of 3, 0.32. Lastly, what is your final answer?
0.0139.
Okay, 0.0139 boleh, 3 at 7 pun boleh. Saya ambil 39 lah. Okay, so now tak answer lagi, baru cari QC. Compare your Q and K value. Q is 10 to the power of, kalau ikutkan 1, 2, 10 power of negative 2. Kalau KC, 10 power of negative 3. Who's got greater value, Q or K? Q. So awak cakap QC is greater than KC. So what kind of conclusions can be made here? Reactions will proceed to which direction?
From right to left.
Okay, reaction will shift from right to left. Okay, so untuk soalan ni 3 markah. The 3 markah comes from first from your substitutions in here. 1, substitution ataupun expressions lah, mana-mana yang betul. And then your QC value. And lastly, your conclusions when you determine the predict the directions of the equilibrium. So 3 markah. Next questions. Calculate the pH of buffer. Dia dah bagi tahu dah pH of buffer prepared by placing 1 liter of solution. So this is going to be the volume of your solution. And then given already the mole for each of your species. Given to you CH3COH and also CH3COOK. Can I know what kind of buffer solutions do you have in here? Acidic or basic?
Acidic.
Acidic buffer because you have this weak acid and also its conjugate base salt. And kalau perasan lagi satu, dia bagi awak Ka value kan?
Yeah.
Okay, so now macam mana kita nak kira pH buffer? pH buffer boleh tak guna formula sama dengan negative log H plus je?
tak boleh.
Tak boleh. Jadi awak kena guna apa nama equations tu?
Henderson.
Henderson-Hasselbalch equation. So this is your apa ni? Kita masukkan CH3COOK divided by CH3COOH. Boleh tak terus ambil mole tu masuk dekat dalam these concentrations?
No.
Tak boleh.
No.
Kita ambil dulu dia 0.20 divided by this 1 liter. By right sama je lah nombor dia. Okay, sama je, nasib baik sama. Kalau dia bahagi volume lain, awak yang silap lah nanti. So, nanti awak substitute value. Markah pada substitution saya tak tunjuk dah sebab saya nak cepat. Untuk substitution 1 markah, saya tanda je kat sini. Lepas tu, your pH nanti dapat berapa?
.92.
Yeah, 3.92. So, the second mark comes from this pH value, 3.92. Okay, proceed to question number 5. State which rule or principle was disobeyed. Okay, sekarang ni kita ada this 2S and 2P and you have 2s 2 electrons, 2p 3 electrons. Kalau ikutkan semua kita punya houses ni ada anak panah. Tapi sekarang ni awak tengok kat mana yang salah?
2s.
Dekat 2s. Apa yang kita ada? Both facing upward kan?
Yes.
Okay, kalau antara kita ada berapa principle or rules yang kita kena tahu when assigning this orbital diagram?
3.
3. So
Tiga.
out of the 3, siapa yang akan rule apa yang kita disobey dalam kes ni? Afbau ke?
No.
No. Lagi apa
Paulis.
kita ada? Paulis.
Paulis.
Paulis cakap apa? Paulis cakap apa?
Opposite spin.
Ya, must have opposite spin, ups and down. Tak boleh both facing upward. Lagi satu kita ada siapa?
Hans rule.
Hans Rule cakap apa?
Occupy orbital singly first before pairing up.
Ya, singly before pairing up. Kalau dia minta state je, beritahu state je lah. Tapi kalau ikutkan, kalau kena betulkan, dia punya rupa akan jadi 2s, 2p, 1, 2, 3, 1, 2 macam tu. Okay, so 1 mark comes from this Pauli's exclusions principle. Okay, next question. How many sigma, pi and lone pair present in the most plausible structure of SO3? You need to first start by calculating apa? Number of valence. So S, we got 6 electrons. 3O, 6 times 3, 18 electrons. This comes from period 3. This one comes from period 2. So altogether you have 24 electrons. So then you have this S, 1, 2, 3 minus 6, left with 18 electrons. So 18 electrons distribute to all 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, lepas tu nak buat apa? Tengok S tu, S period 3. Dia ada possibility untuk form apa? Dia punya stability. We have to learn about 3 types of stability.
Expand.
Expansion kan? Expansion pula. Expanded. Okay, so expanded by right. Boleh tak lebih pada 8?
Boleh.
Okay, at the moment you only have 3 kan? 3 maksudnya 6 kan?
Ya.
Okay,
Betul.
since awak ada banyak lone pair elektron sekeliling awak S ni, dia boleh donate sini satu. Kalau donate situ satu, awak dah capai most plausible structure ke? Dah achieve belum most plausible structure? What do you mean, what do you understand from the term most plausible? Kena ikut priority kan?
Betul, Miss.
Okay, what are the 3 priorities? The first priority comes from all atoms must have
Zero formal
Zero
charge.
formal.
zero formal charge. Can this structure form zero formal charge? Boleh tak agak-agak zero formal charge semua?
No.
Kenapa no? Cuba awak tengok dia bagi SO3. Ada tak any negative or positive charge?
No.
No.
No kan? Maksudnya ada tak possibility berdapat semua kosong?
Ada.
Yes.
Ada. Jadi boleh cuba try dapatkan dia sampai kosong. Kalau awak donate hanya satu, awak buat macam ni. If you check kan, sini awak dapat kosong. The rest awak masih dapat negative, right?
Betul.
Nah, S pun kalau kita ada 6 tolak 1, 2, 3, 4 baru dapat positif tu. Kita kena try tu bagi dia ni jadi kosong. So untuk bagi dia jadi kosong, awak punya structure akan dapat 1, 2, 3 with 2 lone pair each. Kalau kita check, ini pun kosong, ini pun kosong. Okay, tapi dia minta sigma pi dengan lone pair. Berapa sigma, berapa pi, berapa lone pair? Sigma yang mana?
3 sigma.
3 sigma
Three
comes
sigma.
from each single bond here. So maksudnya the rest akan belong to
Pi
Pi.
pi. So kita ada 3 sigma, 3 pi. What about the lone pair?
6 lone pair.
6 lone pair, 2 each on each oxygen. So kita ada 6 lone pair. So 3, 3, 6. So semua ni satu markah. Okay, name the orbital involved in the formations of sigma bond between sulfur and oxygen atom. By using the same structure here, tengok sulfur dengan oxygen sama dia kan? Sulfur, oxygen semua bahagian pun.
Yes.
Okay, dia nak tengok siapa yang buat sigma bond. Sigma bond kita tahu ada yang melibatkan hybrid orbital juga. Jadi awak tengok S tu boleh tak buat hybrid orbital? S boleh tak buat hybrid orbital?
Boleh.
Boleh sebab dia
Central atom.
okay, bila dia central atom, macam mana kita nak tentukan hybridizations of an atom? Kalau tak buat orbital diagram. Kita nak tengok apa?
Electron group.
Yes, electron group of S. Cuba tengok electron group of S apa yang ada. 1, 2, 3 kan? Betul tak?
Betul.
Kalau S awak tengok, S sekarang kita ada S tambah P tambah P. Maksudnya dia adalah
SP square.
sp2 of S. Kalau awak tengok oksigen pula, oksigen awak, apa keliling dia?
Lone pair.
Lone pair 1, 2, lepas tu kita ada bonding pair 3 kan?
Yes.
Sama tak macam tadi?
Sama.
Sama, dia dapat sp2 of O. So, sigma bond is formed between sp2 of S and also sp2 of O. So, sini satu markah. Okay. Right, a vessel holds all the class kan? Tak sempat. Tak apa, sekejap lagi saya upload this answer. Awak habiskan tanda sekejap lagi. Nanti terus upload dekat masuk dekat awak punya ni Make sure yang buat sahaja. Jujur dengan saya. Saya tahu tadi ada orang yang masuk lambat tu mesti dia tak boleh buat apa-apa. So kosong lah. Buat maksudnya kena buat dia punya pembetulan.
Okay, Miss.
Salin balik apa benda nanti saya attach this answer
Okay.
Okay, Miss.
Okay,
Okay,
bye.
Miss.
Thank you. Assalamualaikum.
Thank you, Miss.
Yeah.
Thank you, Miss.
Yup.